Okay, I would like to have a quick talk about composite shapes, and in particular we want to find the perimeter of a shape. We know that we can find the perimeter by simply adding all of the sides together. So here's the shape that we've got, and okay, well, I spotted a problem. This side's fine, 8 centimeters and 4 centimeters and 10 centimeters, but we don't have a length here. Oh dear. What do we do? Well, it's a secret Pythagoras question. Oh yeah, you didn't see that coming, did you? Well, you might have, considering it was the next question on. And it's so we know that when we're doing Pythagoras questions, we need to have triangles. Well, there's no triangle here. So what can we do? Well, we can actually add it in. So let's do that. Here I'm going to just drop in a little line so that I have a right-angled triangle right there. Okay, so now that I have that, I need to think about my sides. What do I have going on here? Okay, so I'm going to have a look and a bit of a think about the sides of my triangle. I've got my A, my B, and my C. Well, I know my C. That's going to be easy. That is just my X value. Oh, let me get a pen size you can see. That's my X value. Okay, I know that that's going to be that. Okay, well, what about my B size? Well, I generally, with the triangles, I generally tend to make the longer of the sides B and the shorter A. You don't have to. You can do them in any order you like. But I'll do that. I'm going to stick with that sort of idea. So my B is going to be 4 centimeters. But my A, I need to know the distance from here to here for my A value. And that's pretty easy. I know that the whole distance from here all the way to there is 10 centimeters. And I know that the distance from here to the end is 8 centimeters. So 10 centimeters minus 8 centimeters, I know my A is going to be 2 centimeters. Easy enough. All right, just like any Pythagoras question then, we are going to write out our formula. We are going to say that C squared is equal to A squared plus B squared. I'm then going to substitute in my values. Okay, I can calculate those. It's going to be 4 plus 16, gives me 20. But I know I need to find the square root of both sides because I need x, not x squared. I will do that, and I get about 4.47 centimeters. Job's done. Except that wasn't actually the question. What was the question I was being asked? Find the perimeter. So now I have a value for that x. All I need to do is just add those sides together and I'll have my perimeter value. Done. Okay, so yeah, this is really about thinking about where can you apply this Pythagoras, trying to find situations where you can use it because it's pretty useful. Okay, let's have a look at another question. You might end up with a question like this. And you've got two unknowns here. I've got an x that's unknown and I have a y that's unknown. And so the question might be written in terms of find the value of y. Right? Well, okay, sure, I could do that. I know my c squared is equal to a squared plus b squared. I'm going to substitute in. I'm going to see for my big, where my y is. All right, I'm going to do that. It will be 15 squared. The shorter values, the a, the x squared plus the y squared. And now I've hit a problem. I've got two unknowns here. This is not an easy thing to solve. So what I'm going to do is I'm going to ignore all of this for the time being. I'm going to put a pin in that. And I'm going to actually just solve this smaller triangle first to get myself an x value. Because once I have this x value, I can come back to this. I'll revisit this later, further down the question. All right, so I'm going to write my formula with a as my subject, a squared. I'm going to do my substituting. I know that my a squared is really written as an x up there. I could write them in. I could say that my a is there and my B is there and my C is here. You could do that. If that helps you not get lost, then by all means do that. I'm not going to write it every time here though, just because I don't normally do that. Okay, so we can work the rest of this out then. 36 minus 4 will be 32. I need to take the square root of both sides, and I'll get about 5.66. So that's an important number, and we're going to remember that one, 5.66. In fact, what I'm going to do with it is I'm going to put it onto my actual drawing. I'm going to redraw it here with my value of 5.66 as our length. Now, it's important to remember how I got 5.66, and I've left it up on the screen just above here so we can remember that 5.66 really is a rounded off number. I really have the square root of 32. Now, if I grab my handy dandy calculator here and I actually do the, oh, that's the wrong button, the square root of 32, you'll see that my answer is actually 5.65854, and that goes on and on, that number. It's irrational. But I can't write all of those decimal places on our work, on our book. We'd just be there forever. Infinite amount of time, actually. So what I'm going to do is I'm going to remember in my head, and you could write it down as well, if that helps, that I've really got the square root of 32 over here, but I'm just going to write 5.66. Fair enough. So I have that number, and I'm going to now attempt to find my value of y. So once again, I'm going to put in here, this is the length that I want, but this is my formula. One of the sides of the triangle will be equal to the hypotenuse minus the side. Now you'll notice that I didn't actually keep the short side as my a here, just to show you that you can do these in any order and it doesn't matter. So long as you've got it and you maintain it once you've started, you're fine. Okay, so I'm going to substitute in my values here, and for my value of my b, you'll see that I actually kept that as the square root of 32. Okay, now it's important to do that because, let me show you, if I kept that as 5.66 and I square that, I actually get a number that's slightly bigger than that 32. And it will actually make my value for y be a slightly incorrect because I rounded off. So you're better off keeping it as that root 32 in this line here. Now I can actually do this calculation. It's easy enough. I can say that my 15 squared is 225, and the square root of 32 squared is just 32, which is nice and neat. I do the takeaway. I then find the square root of both sides. I need to give myself some room. And I will find that my answer is 13.89. Okay, so important to remember then that if you can keep a value that is complete, you should keep that. Even though we might round off when we write it down, we can actually write it as the square root of 32. That's okay. Okay, so that's how we would use these ideas of this Pythagoras Theorem and help us to solve questions that don't particularly look like Pythagoras to start with sometimes, but we can still use it. This idea that triangles have values that we can determine using that theorem.